Hello guys, and welcome back to another episode of chemistry. And of course, we're going to continue our study of alkanols. All right, and that is chemistry. Okay, we are going to talk about reactions of alkanols. Okay, the reactions that alkanols would undergo is what we're going to look at today. Do not forget that this tutorial is brought to you by the one and only O3 Schools JAMB CBT Practice app. Millions of students are in school today because of that application, and your case will not be different. So please do not sleep on the app. Download it and activate it immediately for sure success in your exam. Look at our testimonies. Of course, you see how the app has helped thousands and millions of students. Let us go on. Let us see a question from the app. This is a 2019 question. Okay, number one, as it relates to reactions of alkanols. It says, a secondary alkanol can be oxidized to give a secondary alkanol. It's a 2019 question number one. A secondary alkanol can be oxidized to give A, alkyne, B, alkanal, C, alkanone, D, alkanoic acid. All right. So we will come back to this question and many more questions that as it relates to reactions of alkanols at the end of the class and not before. The reason is that we believe in O3 Schools that we need to give you value. Let us teach you first. Make you know one, make it in your head. Then we can now answer question, and that will make everything mende. All right, so please, I would like to see you at the end of the class. So please go and make sure you get your application from Play Store. Go to Play Store, download it. There's a software version also. All right, so please ensure you have all those applications and start studying. The app has all the past questions you need to succeed in your exam. So no need to go and buy past question for all subjects in the app. All right, then of course we have lecture notes structured according to the JAMB syllabus. All right, some of you do not read it with your JAMB syllabus. I pity you and laugh you in Korean. All right, please ensure that what you study with your JAMB syllabus, and that is what this app has. Okay, the lecture notes are according to the JAMB syllabus, so you don't need to worry about going to buy textbook anywhere. What's more, there's a question search feature where you can search for question according to topic. So you can just go and search for reactions of alkanols now, or just search for alkanols. All the questions that JAMB said, all the gbogbo tier that JAMB said that concerns alkanols will come out for you to answer. What's more, again, there's a mock challenge every Saturday till 1 week to your JAMB exam. You participate in that mock exam, or that compete with your mates, get used to JAMB past question, get used to JAMB likely exam questions. See your score release every Saturday like real JAMB. So that will build your confidence. You know, good if you they say it's mainly 1 week to JAMB, okay? Because you know that you are fully prepared. So the app is fully loaded for your success. Get the app, activate it. Activation fee is just a little fee. Pay the sacrifice, activate it. Let's go to the board. Let's look at the reactions of alkanols. So alkanols usually undergo several reactions. Okay, even elimination, even substitution, oxidation, and the likes. So these reactions are what we're going to be looking at today. But before we do that, please make sure you have liked this video. If you have not liked this video, what you are doing is very wrong. Now, wickedness, okay? Because you do not want other people to see this video. That's why you're not liking it. So please, as you're watching now, don't click on that like button. All right, it will make other students easily find this video. You know, go hard them. So YouTube will be recommending it to them. And then do not forget to subscribe to this channel. Subscription is free. So if you have not subscribed before, click on that red subscribe button. And of course, if you have not been sharing our videos to your friends, to your loved ones, to your classmates, to your enemies, keep sharing. Click on that share button and start immediately. So let us see reactions of alkanols. And number one, the first reaction we're going to be looking at is combustion. Okay, reaction. Okay, so which is of course the reaction with what? With oxygen. Reaction with oxygen. All right, so this means that what alcohols, all right, can react with oxygen, and this is a quite desirable reaction. Why did I say it is desirable? I don't know if you have seen all those people that will put alcohol in their mouth and then now light fire, then fire will now be coming out from their mouth. And I say, hey, this guy doing magic, he's doing magic. Let's go and watch magic. All right, it's because alcohol itself is quite flammable. All right, so it can catch fire. All right, so that is why they are able to do that. They put alcohol in your mouth now and then light fire, it will catch. So the reaction is quite flammable. And Alcohols, they burn just like normal hydrocarbons to release what? Carbon dioxide and what? And water as products for complete combustion. And for incomplete combustion, they release carbon monoxide and what? And water. So please take note of that. So combustion reaction, okay, is one of the reactions that what the alkanols what undergo. Okay, like I said, it is quite what? A desirable reaction for them to undergo. Let us see. Let's say like an alcohol like ethanol, C2H5OH, all right, reacting with oxygen. Let me just write the balance equation once and for all. 3 molecules of oxygen, then this will give us 3 molecules of water plus CO2, 2 molecules, all right, where this one is ethanol, this one is what? Oxygen, okay, and then this is what? Water, and this is what? Carbon dioxide. Okay, so this is what? The case of what? Complete combustion. Complete what? Combustion, where what? The ethanol burns completely, all right? But in the case of incomplete combustion, it does not give us what? Hydrogen and water and what? And carbon dioxide. Instead, we usually have what? Carbon monoxide and what? And water as the product. Okay, so please take note of what? Of that. So alcohols burn just like normal hydrocarbons. They burn just like normal hydrocarbons. So that is the first what? Reaction. Okay, that's what the alcohols undergo that we just looked at. Now let us look at also number 2, dehydration of alcohols as the second what? Reaction. Dehydration of alkanols or what? Alcohols. Can call it what? Alcohols. All right. So we usually do this what? In the presence of what? Of H3PO4. Okay, and of course we will do what? Reflux. Okay, whenever you see reflux, it means that what? That the reaction is controlled. It's controlled. Okay, it's controlled so that what we have what? A product. Okay, so the reaction is what? Is controlled. That's why we're seeing what? Reflux. So we do this in the presence of this, and of course dehydration of alcohols or alkanols will give us what? An alkene. Abi? I think we have done in the last class we threw what? An hint on that. So dehydration of alkanols will give us what? An alkene. It's as simple as ABC. All right. So why what? Hydration of an alkene will give us what? An alcohol. All right. So note that the reverse is what? Is the hydration of what? Of alkenes. Okay. But dehydration of alkanols or an alcohol will give us what? An alkene. So let us see that reaction. All right, so dehydration of alcohols. All right, so we're going to have C. Then let's say we have what? OH here. Okay, H. This is our ethanol. Okay, this is ethanol. Okay, so once we dehydrate what? Ethanol, right? In the presence of what now? H3PO4, phosphoric what? Acid. And of course, we are carrying out the reflux, as we said. So we are controlling the reaction so that we have what? Our product. What I'm going to have is an alkene. Okay, corresponding alkene that has what? 2 carbon atoms, just as what? As the alcohol. All right. So what we're having here, I'm going to have what? Our alkene. I C. All right. Double bond, right? Double bonded to what? To C. We can complete our structure. All right. Okay. Bam. 1, 2, 3, 4. 1, 2, 3, 4. This is our H. This is our H. This is our H. This is our H. So we are going to what? I have what? An alkene. All right. And of course, if you check very well, our reaction will not be balanced. So we have to what? Complete it with what? H2O. Okay. So our reaction will be what? Will be balanced. All right. So if you notice something again, you should know that what? This is an elimination reaction because we are eliminating the alcohol. All right. We are eliminating water. Okay, we are removing water, or that we are eliminating water, and then we are getting what? An alkene. Okay, this is an elimination reaction. And for generally in organic chemistry, right? You know, we usually mostly talk about addition reactions, substitution reaction, elimination reactions. Okay, so once, for example, we have what? One reactant. Once we have one reactant giving us 2 products. Look at one reactant here, ethanol, giving us 2 products. This is what now? Ethene. Then this is water. Okay, so one reactant, this is one reactant giving us what? 2 products. Just know that that is what? An elimination reaction. Take note of, all right? So elimination reaction, usually one reactant will give us 2 products in elimination reactions. Take note of that, all right? So what type of reaction is this? Just know, just look at the reactant. One reactant, how many products? 2 products. know that's what is an elimination reaction. What about if we have, for example, two reactants? We have two reactants giving us two products. Once we have two reactants, A plus B, giving us C plus D, know that it's a what? It's a substitution reaction. Okay, that is what a substitution reaction. Once you have two reactants giving us two products, it's a what? It's a substitution reaction. But if we have two reactants now giving us one product, the reverse here, having two reactants giving us what? One product, that is an addition reaction. That is an addition reaction. So as you can see, evidently, this reaction here is an elimination reaction. But the important thing to note here when it comes to what? Dehydration, okay, of what? Of alcohols is what? Is the hydrogen to want to eliminate. Remember that we are what? We are removing water. Hope you know. We actually was removing what? Water from what? From the alcohol. Because that is what dehydration. That's what dehydration is. Removal of what? Of water. We are eliminating water. So we have this OH here that will be removed. But water, the formula for water is H2O, not just OH. So we are removing what? H2O. So if we remove OH, we'll see there's another H that will remove. Where are we going to remove the OH from? All right. So where will the double bond be formed? This is another very important thing. Okay, so let me now use the word a carbon atom. Okay, sorry, an alcohol that has maybe 4 carbon atoms. All right. So for example, if we have C, 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 C. All right. Then here we have what? OH. Bang, 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 H, 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 H. Okay, so this is our what? What's the name of this compound? 4 carbon atoms, butane. That's what butan what? 2-ol. If you count from here, 1, 2, 3, 4. All right, because the closest here is what is 2. If you count from here, 1, 2, 3. So that will go butan 2-ol. Right. So if you want to dehydrate butan 2-ol, all right. So where we are going to remove this OH, right? Definitely. So where we now remove what the other what H from, right? So where we are going to place our double bond. So if we are having butan 2-ol, if we want to dehydrate this, we are going to have what now as our product? C double bonded to C. Double will be formed, okay, from here and here. All right, I have to remove what? This H from what? From this what? From this first carbon. Okay, so I'm going to have C double bonded to C. I'm going to have what? C, C, and complete your structure. All right, so you know what that compound is, right? This is 1, 2. That's what butene, okay? That will be our butene, then plus what? Our H2O. So now, let's say it was actually here. This OH was here, not here. This OH was here and here. So we remove what? This OH and remove this H. So the double bond will be formed between here, not here again. So for this case now, since we have switched places, the double bond will be formed here. You must take note of what? Of that. All right, so open your eyes, shine your eyes, and understand. If you do not understand the video, take the video back. You have the liberty of watching this video 1 million times. Get it and get it. For you see it in your exam question, you go to your past question, open your O2 school JAMB, you see this kind of question. So that is the second method that we use in what? In producing, I say method. That's the second reaction we're considering as it pertains to the alkanols. Okay, dehydration of what? Of alkanols gives us what? The corresponding what? Alkene plus water. All right, so let us see another reaction. As reaction what now? Number 3. So this one is substitution reaction. Substitution what? Reaction. Okay, and this one, alcohols react with hydrogen halides, okay, to give us an haloalkene. Okay, alcohols react with what? Hydrogen halide to give us an haloalkene. Okay, here let me say alcohols react with hydrogen halides, okay, to what? To give us a haloalkene, okay, or an halogenoalkene as you may have it. Okay, so that is what substitution what reaction is. A substitution reaction. Okay, an alcohol what reacts with hydrogen what halide to give us what? and haloalkane. And know that what in this reaction, we are going to have 2 reactants, then we are going to also have 2 products. Okay, that is why it is what? It is what? A substitution reaction. 2 reactant, 2 product. 2 reactant, 2 product for substitution reaction. So let us go. So now, the general formula for the reaction, obviously, this is what ROH. This is what? An alcohol. Okay, so reacting with what? An hydrogen halide. Okay, let's say HX. All right, then this is what? The hydrogen halide. Hydrogen halide. All right, then of course, this will now give us what now? To give us what? An haloalkane. All right, and haloalkane having what? Where what the what do you call the alcohol has now removed. So I'm going to have what now? Our arrow. All right, I'm going to have our arrow what? H. Okay, then plus what now? Then plus water. Plus water. All right, so that's what it's going to what? Going to give us. Right, I'm going to have what? An haloalkane. This is what? An haloalkane. And then this is what? Water as product. Okay, so you must take note of that. And of course, among the hydrogen halides, we have what? Hydrogen iodide, hydrogen chloride, hydrogen what? Bromide. All right. Alcohols react better with hydrogen bromide. You must take note of that. Okay, so they react much more better. They are more reactive with what? With hydrogen bromide than what? Hydrogen chloride and hydrogen iodide. Take note of that. All right, so that's why the halogen we're going to use here is what? Is bromine. All right, because it is more favorable to the alcohols. Okay, so let's all see. If you have what? An alcohol like ethanol, like C2H5OH, or let me just draw the structure. Like if I have OH, sorry, not C, here, H, here H, here H, here H, here H. Okay, so now reacting with what now? Because I'm going to have 2 products with hydrogen what? Bromide, HB what? R. All right, so this will give us what now? I'm going to now have what? Our haloalkane, C. Okay, in place of this alcohol, I'm going to have our bromine there. Okay, H, then plus what? Our water. All right, so that is what the reaction. But please, you must take note that what? That this reaction, we do not just react the alcohol with hydrogen bromide directly. Okay, we have to first of all produce this hydrogen bromide in a test tube. You must produce this hydrogen bromide in a test tube. It's very, very important. Okay, so how do you produce this what? Hydrogen bromide in a test tube? We use what? Sodium bromide and react it with what? Concentrated tetraoxosulfuric acid. So we react sodium bromide with concentrated tetraoxosulfuric acid. Then it will now release for us this what? Hydrogen bromide and what? Sodium hydrogen tetraoxosulfuric. Okay, then now we'll now have the reaction. So the first step, this is not the first step. This is like the final thing. This is the final thing we're looking for. But what happens first is that what? We have to first react sodium bromide plus what? H2SO4, which is concentrated tetraoxosulfuric. Okay, H2SO4. Then this will now give us what now? To now give us our HBr, then plus what now? Na. Though there's one H here that is left. HSO4. This is the first step. This is actually the first step. Okay, so this hydrogen bromide I will now use to react with this alcohol to now give us what? This haloalkane we're talking about. So that the general formula for the reaction will actually be what? Look at our ethanol, C, OH, H, 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 H. This is our ethanol. Then we will now react. Okay, we'll now react it with what? With NABR plus H2SO4, because it will now, this is what will release the HBr for us. So now this will now give us what now? In the product side, I'm now going to have what? Our haloalkane, our C, H, Br, our H, then plus what now? Plus N, plus H2O, then plus what? NaHSO4. Okay, this will now be our complete what? Reaction. But these ones are not important to put on here. This is one that you should just take note of. Okay, I'm just trying to tell you that what? We cannot use hydrogen bromide directly. we need to first of all produce this hydrogen bromide in a test tube. And how do we produce this? We react our sodium bromide with what tetrasulfuric acid, and then we now release of our HBRO, which we now use for this reaction. Okay, this is the process. This is actually the first step. This is the second step, the final step for the reaction. But this is the general equation for the reaction. So if you want to produce HBRO, you need to first of all do this first. Okay, or just do this directly. All right, so that is that for that. That's substitution reaction. The third reaction we are looking into as it pertains to the alkanols. You can see my throat is getting dry, and somebody will still be watching this video without liking it. Somebody will not share this video to their friends, to their WhatsApp group, to their families, to their friends who need it. That is wickedness. So please ensure that you keep liking, you keep subscribing. Okay, so let us go to the fourth reaction. This reaction is called oxidation reaction. All right, oxidation reaction. Let us see oxidation reaction. First of all, we know that oxidation. Well, first of all, did oxidation and reduction, we say that oxidation is the loss of electrons. Okay, is the loss of electrons. But in organic chemistry, whenever we're talking about oxidation, all right, we usually use it to mean addition. Okay, that we are adding oxygen to a compound. All right, that's what it usually means. Let us see number 4. That is oxidation reaction. All right, so we said that oxidation is the loss of electrons, okay? But when it comes to organic chemistry, what we really mean when we talk about oxidation is that we are adding oxygen, okay, to a species, all right? And the reverse or the opposite will mean that we are removing hydrogen. Okay, so if we're adding oxygen, the reverse is is that we're removing hydrogen from it. Okay, so we must take note of that. And we say that that an oxidizing agent is one that becomes reduced. Okay, that becomes reduced at the end of the reaction. So when it comes to oxidation reactions of alkanols or alcohols, all right, what happens is that we use an oxidizing agent, and we usually represent this oxidizing agent with O like this, okay, in brackets. Okay, and the agent that we usually use is potassium dichromate. Okay, and the oxidizing agent that we usually use is potassium dichromate. You must take note of that. Okay, and of course for all of the type of classes of alkanols, primary, secondary, and tertiary, we use the same oxidizing agent for all of them. We use the same oxidizing agent for all of them. So this potassium dichromate is K2Cr2O7. All right, and from the beginning, this chromium has an oxidation of +6. Okay, if you calculate it, it has an oxidation of +6. But at the end of the reaction, because an oxidizing agent will become reduced. Okay, when you add an oxidizing agent to a species, what happens to that? It becomes reduced. So it now becomes reduced to +3 in the end. All right, the color of this K2Cr2O7, why it has not been reduced, it's actually it actually has a bright orange color, bright orange color. But later on, what happens is that after it has been reduced, it becomes green in color. Okay, so you must take note of that. So for us to do oxidation reaction, first thing we need to first signify or classify the alcohol. Is it a primary alcohol? Is it a secondary alcohol? Is it a tertiary alcohol? All right, so what we do first of all is to classify. So now let's talk about primary alcohols. Primary alcohols or alkanols. Primary alkanols, okay, when oxidation happens, okay, to a primary alcohol, okay, it changes it, okay, it oxidizes it to an aldehyde. Okay, an aldehyde is an alkanal, okay, plus it gives us an alkanal plus water. All right, then it could also give us give us carboxylic acid. It can also get oxidized to carboxylic acid. Okay, depending on whether we carry out reflux or distillation. Okay, I told you what reflux means. Reflux means that we are controlling the reaction. Okay, we are controlling the reaction. But distillation, if we are looking for purity, okay, for purity, we're looking for a pure something. Okay, something pure. We carry out distillation. But if we are looking for, I want to control the reaction. Okay, so that we have a desired product. What to do is reflux. You get me now? So now that is that for that. So for distillation, it gives us what an aldehyde. Okay, while for reflux, it oxidizes it to what? To a carboxylic acid. You must take note of what of that. So in general, it means that what that primary alkanols are oxidized to what? Aldehyde or what? Carboxylic what? Acid. Take note of it. Primary alcohols or alkanols are what? Oxidized to what? To aldehyde or carboxylic what? Acids. Let us see an example. So we have primary alkanols here. Primary alkanol, you know what a primary alkanol is, right? Okay, we say a primary alkanol from the previous classes when we did classification of alcohols. We say a primary alkanol is an alkanol, okay, whereby the carbon bearing the OH group, all right, has attached to itself only one alkyl group. One alkyl group is attached to the carbon bearing the OH group, all right? So for primary alkanols, what do we have? For example, ethanol. Ethanol is a primary alcohol. So let me just draw the structure. Let me say C. Okay, OH, H. Okay, so this is a primary what? Alkanol. This is the carbon that is bearing the what? The OH group, right? So what happens is that this what becomes what? Oxidized. All right, so basically what we do, we use what? Either concentrated tetraphosphoric acid or phosphoric acid. Okay, and then of course we carry out now distillation. For distillation, if you carry out distillation, let's say here we use what? Conc H3, sorry, not conc. So sorry, for oxidation, we only use K2 CR2O7, please. So it's acidified, okay? We use acidified. Take note, please. We use acidified K2CR2O7. So I'm going to use what? K2CR2O7 acidified, that is what? H2SO4. Okay, it is acidified potassium dichromate. Then now we're carrying out what? Distillation. So if you carry out distillation, what it gives to us is what? Is an aldehyde or an alkanal plus water. Okay, so now this will form an what? An alkanal or an aldehyde. All right, double it to O. Okay, then H, down, bar. This is what now? And what? An aldehyde. Aldehyde, then plus what? Plus water. This is what it gives to us. So now, but if we carry out this is distillation, but if we carry out what now? Reflux, COH, H. Okay, so this goes it's the same condition, K2CR2O7 acidified. So that is H2SO4. Now we're carrying out what? Reflux. Okay, so what this will give to us now, all right, is not what an aldehyde, to give us a carboxylic acid. I'm going to have C, double bonded to O, OH, H, plus what now? Plus H2O. All right, so this is what now? A carboxylic what? Acid. All right, so generally, as we said, that's what a primary alkanol will get oxidized. All right, from what now? We get oxidized to what? To an aldehyde or what? A carboxylic acid what? Group. Okay, a primary alkanol gets oxidized. That's the major point you should take note of here. It gets oxidized to aldehyde or carboxylic acid. Get oxidized to aldehyde or carboxylic acid. Get oxidized to aldehyde or carboxylic acid. I'm repeating it because it's an exam question. You will see it. All right. So you will see it. So make sure you want to take note of that. And the color change is usually from what? From orange to what now? To green. Okay. The color change is from orange to green. Take note of that. Now, let us now go to secondary alcohols. That is primary alcohols. Let's go to secondary alcohols. So we do not carry out distillation for secondary alcohols. We do not carry out distillation for tertiary alcohols. Okay, so we only carry out distillation for primary alcohols. All right. So for secondary alcohols, secondary alkanols or alcohols. All right. So what happens is that what? They get oxidized to ketone. They get oxidized to what? To ketone. Take note of what? Of that. Secondary alkanols get oxidized to ketone. So a secondary alkanol like a propan-2-ol 2-ol. Okay, we get oxidized to what? To a ketone, okay, or a propanone. All right. So let us see. This is propan. Let us draw a propan 2-O. Okay, that's what our OH. Propan having what? 3 carbon atoms. All right. H. All right. The same condition. K2Cr2O7 acidified. Okay, let me just put H2SO4 to show that what it is acidified. So we cannot carry out distillation. So we can only carry out what? Reflux. Control the reaction. Then it give us what? A ketone. C double to O. Okay, or and put it what? Double to O. Okay, then C. Ba. H. Okay, then what? H. 1, 2, 3, 4. It's complete now. All right, so these are what? Our propanone, which is what? A ketone. All right, so please take note of that. Of course, plus water plus H2O. All right, so that is that. So secondary alkanols what get oxidized to what? To a ketone. Primary alkanols get oxidized to what? To carboxylic acid or aldehyde. While secondary alkanols get oxidized to what? To ketone. All right. Then now, tertiary alkanols, the reaction does not occur. Okay. So tertiary alkanols do not get oxidized. They do not get oxidized. Okay. So if you react them with what? K2Cr2O7, what happens is that they remain orange. They do not change from orange to green. But secondary alkanols and primary alkanols will change from what? Orange to green. Okay, so that will now take us to our last reaction, which is what? The sweet reaction called esterification. Esterification reaction. All of you that your name is Esther, I think you will like this one. Okay. And esterification reaction is a reaction between an alkanoic acid with an reaction between an alkanol plus an alkanoic acid to form what? Ester and water. Okay, as products. Okay, so esterification reaction is a reaction. When we talk about esters, we'll see get to esters and how to name esters and the likes. Okay, so esterification reaction is a reaction between an alkanol and an alkanoic acid to give us what? An ester and what? Water. So let's say we have what? An alkanol like what? Ethanol, C2H5OH, and then let's say we have an alkanoic acid like ethanoic acid, like CH3COOH. Then what would give us it? What is an ester? Okay, what I'm going to have CH3COOC2H5 plus H2O. All right, this is our ethanol. Okay, this is our ethanoic acid. And then this is what now? Our ethyl ethanoate. Okay, and then this is our water. Okay, so this is our ester that is formed here. Okay, and ethyl ethanoate. All right, so we'll talk about the name ester soon. So do not worry, bring your mind down. Relax. Master T got you. All right, so let us go to the application, answer questions, and we'll run out of here because of time. 2019 number 1, that a secondary alkanol can be oxidized to give, obviously there is what? An alkanone, all right, or a ketone. It's a ketone, or what? Also called what? Alkanone. Okay, so that means if you do not see, for primary alkanol, if you do not see aldehyde, you should see what? Alkanal. But some of you don't know that it's the same thing. Okay, ketones are also called alkanones. All right, now let's see. No, 2004 number 16. 2004 number 16. It says C2H5OH. It is being displayed on your screen right now. All right, that's dehydration. All right, so dehydration of what? Ethanol gives us what? A corresponding what? Alkene having 2 carbon atoms, and the alkene that has 2 carbon atoms is what? Is 18. Okay, so our correct answer there will be 18, which is option B. Like to say, they said this question. We are not playing here. Let's go. Dehydration of, I'm giving a compound there. That's 1998, number 42. 1998, number 42. They said that what? Dehydration of CH3, CH2, CH2, CH3, CH2, CH2, CH2OH. Okay, dehydration of this compound gives us what? All right. So where is the OH what located? Okay. So if you want to draw this compound, this will be C. Let us draw it out. H. Okay. Then of course we now have what our CH, our C, H. Then our C again. H. So I have our OH somewhere here. Okay, I'll just put our H here. Let's say I have our OH somewhere here. Okay, so obviously, what we're going to do is what? We're removing this dehydration. Now we're removing what? We're removing what? H2O. We're removing water. Okay, so we're going to what? Remove what? This OH and this H. Okay, that means our double bond should be formed somewhere here. And what it gives to us is what's an alkene. Okay, it gives us an alkene. So look at the first option. Option A here is an alkyne. A is wrong. A cannot be the answer. A is very, very wrong. All right, because it's an alkyne. Dehydration of alcohols do not give us alkynes. It gives us alkenes. Alkenes, not alkynes. B, the option there is an alkene, but you can see where the position of double bond is. Where the position of double bond is, there is here. Is somewhere here. Okay, it's here. It's not supposed to be actually here. Okay, it's not supposed to be here, it's supposed to be somewhere here. All right, but let us cut them some slack. Let us look at option C. Option C says C triple bond there. I see a triple bond, that's an alkyne, so cannot be the answer. Option D, triple bond, cannot be the answer. The only closest answer there so is option B. Okay, so you didn't see none of the above there? No, if you like, no use of sense. Say answer no D and no dey pick answer. The answer there is option B. All right, let's take note of that. Okay. Now, they said that the reaction 1997, number 42, 1997, number 42, says the reaction of an alkanol with an alkanoic acid in the presence of concentrated H2SO4 will produce what? An ester. Okay, that is esterification reaction. That reaction, look at what esterification, and those are esters are called what? Alkanoids. Okay, they're called alkanoids. That's why option B is very correct. All right, so okay, I think I've seen this other question. 2023, number 1. What type of reaction is involved in the formation of alkanols from alkenes? Alkanols from alkenes, all right? A, substitution reaction. B, addition. C, elimination. D, redox. Okay, correct answer there will be what? Will be addition reactions. All right. Okay, so like in the next class now, I'm going to be looking at test for alkanols. We're going to look at a test for alkanol. We see that a question comes out under it also. Then we look at the uses of alkanols, and then we're done with alkanols. We move on to alkanoic acids, okay, or the carboxylic acids. My name is Master T, the Grand Master of O3 Schools Army. Okay, I'm the Grand Commander. I'm a soldier, and you are a soldier. Believe that you must be marching on. You must be studying. You must be ready to take the bull by the horn and succeed in your exam. I'll see you in the next class. Thank you for staying with me.